In this video, we'll take a look at solving a total value problem in two variables, which will generate two equations, and then use the elimination method to solve. Entering Yellowstone National Park costs $20 for a car and $15 for a motorcycle. On a typical day, 5,950 cars or motorcycles enter and pay a total of $107,875. How many motorcycles enter on a typical day? So we're talking about two different variables here, cars and motorcycles, with the question asking us simply how many motorcycles enter. We will need to generate two equations because of the fact that we have two unknowns. So here, using this first piece of information with regards to total number of vehicles entering the park, our equation will be number of cars, letting C represent the unknown number of cars, plus M, the unknown number of motorcycles, is equal to the total number of vehicles. For a second equation, we'll use the total revenue gathered during the day, which came from the sum of the car revenue. Cars are charged $20, so we'll take $20 times the number of cars plus the revenue generated from motorcycles. Motorcycles are charged $15, so 15 times the number of motorcycles entering the park is equal to the entire revenue. So here's the two equations. Again, the first one talks about the number of vehicles. The second equation talks about the revenue from the vehicles that entered the park. Using the elimination method to solve this system, we want to eliminate one or the other of the variables. In this example, let's eliminate the C's when we add these two equations together, which means the coefficient in this first equation would need to be a -20 so that when they were added together, the C's canceled one another out. To maintain equality, we'll multiply each and every term by -20 for an equivalent equation of the following. We're now set up to add these two equations together. And as you can see, the C's do cancel out. We'll combine like terms for the M and the integers, resulting in the following equation, which has one variable. The only thing left to do to solve this equation then is to divide both sides by -5 to get the variable by itself. M stood for the number of motorcycles, and that was the question: determine the number of motorcycles that entered the park. So essentially we're done. However, many problems do ask for both pieces of information. So if the number of cars had been asked, we would simply replace M with the value that we found, the 2,225, in either one of the equations. Here showing we've used that first equation, replacing M with 2,225. Solving for C, we'll subtract 225 from both sides, resulting in C having a following value listed there. So in the event it had asked for both answers, we would have expressed it as shown here.